let's prove the following identity if z plus 1 over z is 2 cosine alpha. So we can start with this with n is equal to 2 to do some analysis of the problem. So to get the z square plus 1 over z square, we can take the square of both sides of this expression. And see what it gives us. So when you open the parentheses here, that's z square plus 1 over z square. And since this is a plus b square, I will have 2ab term. That's z times 1 over z. That gives me just 2. And 4 cosine square alpha. And then z square plus 1 over z square is 4 cosine square alpha minus 2. If I take out the 2, that's 2 cosine square alpha minus 1. And this is by double angle formula. That's just like cosine 2 alpha. This is double angle formula. These are equal to each other. So if I take the square, I have the identity true for n is equal to 2. Now I want to prove the identity for general case. So in general case, if I want to do, instead of this, if I want to do the power n, opening the parentheses for power n will be very difficult. So instead of that, I can do induction. So I would assume that the expression is true for all n is equal to less than k, and less than or equal to k, and prove the identity for n is equal to k plus 1. Or let's say it will be much easier for us to work with the identities if I assume that it's n, the identity is true for all n k minus 1. We want to prove that it's true for n is equal to k. So in order to get the identity for zk, I will just multiply 1 over z plus 1 over z by zk minus 2 plus 1 over zk minus 2, or minus 1. Minus 1 would be good. Minus 1, minus 1. That's 2 cosine alpha multiplied by 2 cosine k minus 1 alpha. And then if you open the parentheses, you get zk plus 1 over zk plus zk minus 2 zk minus 2. And then this is 4 cosine alpha cosine k minus 1 alpha. So we have the expression for this one. By the assumption of the induction, we know the value of this. So we have zk plus 1 over zk equals, I will just subtract this on the other side. So we have 4 cosine alpha cosine k alpha minus alpha. Let me open the parentheses and write it like this. Subtract 2 cosine k alpha minus 2 alpha. So that's k minus 2 alpha. So that's the expression for zk plus 1 over zk. So if you do some trigonometric identity, work with this identity and simplify this, you can use cosine x minus y formula here, cosine x minus y formula here, open the parentheses, do the simplification, and then this whole thing I expect to simplify to 2 cosine k alpha. So basically I'll just skip this working with the trigonometric identity part, but the main idea of the proof is to multiply these two instead of taking to the power n. So this one makes the calculations much easier. If you want to do and spend a lot of time and energy, you can take to the power n and then do the binomial expansion, but that's a lot of work to do.